In this lecture, we talk about binary search algorithm, which is a very simple and intuitive algorithm, which divides the given array, sorted array, into two halves. Exactly, it identifies the midpoint, and it searches the key value at the middle location. If a key is found at the middle location, fine. Otherwise, if key is on the left hand side, only left subarray will be processed next, or if it lies on the right hand side, it processes the right subarray. This can be implemented in two ways. One is a recursive way, another is iterative way, but implementation is similar. And this is also a divide and conquer type of algorithm, which divides the given array into smaller subarrays. Now we will look into the recursive type of method or algorithm. The input to the algorithm is the given array is taken, and key to be found, and low and high, the least and highest index of the array is given. As long as the low is less than high, we process the algorithm. Whenever the low is greater than high, we stop. If at all such condition arises, we stop. Else, we find out the mid value as the integer part of the average of low and high, low plus high by 2. Integer part will be taken. If it is of odd size, no issue. If it is of even size, array is of even size, then we have to compute the mid value as the integer part of the average of the low and high. So once we get the mid, then we try to identify the element present at the location of mid in the array. So k will be compared with array of mid. Directly, if k matches with the array of the mid, fine, value return is value is returned, index is returned. Otherwise, if k is less than, if k is greater than array of mid, then what we do is we'll call the binary search algorithm again with the changed parameters. So if k is greater than array of mid, that means k lies in the right subarray. So the low will be updated as mid plus 1, because already k is not matching with the array of mid. So low will be updated as array of mid. Low will be updated as mid plus 1. Now binary search algorithm is again called on the right subarray consisting of array, k, mid plus 1 to high. Else, if it is not the case, so k should be less than array of mid. In this case, k lies in the left subarray, so that high will be modified here. High will be reduced to mid minus 1. So again, binary search algorithm will be called on the parameters of array k and low, mid minus 1. So recursively, this process goes on until the only single value is identified. That means the subarrays are reduced progressively until a single value is identified. If at all the key is not found, then we'll come out with low greater than high and return false. That means key is not found. Now we look into an example here. We take an array consisting of 12 elements with indexes, low indexes 0 and high indexes as 11, and the target value is 36. So initially low is 0, high is 11, and now mid value is computed. Integer part of 0 plus 11 by 2, 5. Now the array value at location 5 is 55, and 36, the key value is less than 55, so we should focus on the left subarray of the mid value. Since it is not located at the mid value, high is, this time high is updated as mid minus 1, because it has to shift to left part. So that high becomes 4, and again mid is computed in the subarray consisting of 0 to 4. It becomes to 2. Again, the mid value is once it is computed, the array value at mid is taken as a of 2 is 29. This time 29 is less than 36, the key value, and the right subarray, the newly formed subarray, we need to consider the right subarray because 36 lies to the right of this. So this time low has to be updated from 0 to that mid plus 1, that is 3. Now the new low is 3 and new high is 4. If you compute the integer part of the mid value, it comes out to be 3. And incidentally, that a of 3 coincides with 36, so the value of the index is returned. If at all in such cases still the value is not found, and if we update the mid values, it coincides. I mean, low value exceeds high value, and algorithm stops if at all element is not present. Now, when it comes to the best case, if the array, whatever be the size of the array, once we compute the mid value and directly the required value is coinciding with the mid, then the algorithm stops only with one comparison, whatever be the size. So that becomes the best case. And the worst case will be when the elements are present at the end points. In that case, progressively the array has to be halved at each point, and gradually you have to reach to the end. So that is a worst case scenario because maximum number of comparisons will be required. If the required value is somewhere in the middle to end, in either case, then it becomes the average case.